at home, you are welcome to this special program organized by the Kebbi State government in order to keep you busy at home during this unfortunate break as a result of COVID-19 pandemic. My name is Usman Siaka, a staff of Nagari College, Brennan Kebbi. This is in continuation of what we did in our previous lesson. The subject is mathematics, and our topic is indices. For today, being the 13th day of April 2020. Then the topic is indices. From our previous lesson, we discussed that indices simply means exponents or powers. And this came into existence or being as a result of situations where a certain number is used to multiply itself several times. And from there, we're able to look at the basic laws or rules of indices. Today, we are going to discuss the laws one after the other. And before going into the law, there is one basic tools I want us to understand. In indices, we say a particular number used to multiply itself several times. Here, if we have a number of this form, maybe 2 raised to power 6. In this example here, 2 is called the base, while 6 is called the power or the exponent, as the case may be. This 6, which is the power, shows or tells us how many times this base 2 is used to multiply itself. With what we have on the board here, this indicates that 2 is multiplying itself in 6 places. Now, going to the laws of indices, the first one I want us to look at it is the zero exponent. If a is raised to power 0, the end result is what? Is 1. What we mean by this one is any other number apart from 0 itself raised to power 0 is equal to what? 1. From this analysis here, if we are asked to evaluate or simplify maybe number 1, the current mathematics teacher for this program, otherwise known as Usman. If Usman is raised to power 0, my current value now remains at what? 1. 2. If m is raised to power 0, the value is what? Is 1. If we say Kebbi State raised to power 0 is what? It's going to give us 1, because any other number apart from 0 raised to power 0 is equal to what? 1. If we continue on and on and on for this example, the end result is also what? 1. So we would like to stop with these 3 few examples on 0 exponent. Now, we would like to move to the second law, which is multiplication law. So under multiplication, if we have a raised to power m multiplied by a raised to power n, the end result is what? A raised to power m plus n. With this law, this a and a we are seeing here are called the bases. We have common base here. A is appearing here and a is also appearing here. If we have common bases multiplying themselves, the end result is to add their respective powers. So if we are asked to evaluate one, maybe p raised to power 2 multiplied by p raised to power 5 multiplied by p raised to power of minus 2. P multiplied by p that we are seeing here are the common bases. So we now have only one p. The rule is what? Is to add their respective powers. So we now have the first one as what? 2. Plus the second one as what? 5. Plus the third one as what? Minus 2. We'll put this one in bracket because it contains negative. Now, it will now give us p raised to power what? When we say 2 plus 5, it is equal to 7. But 7 plus minus 2, negative is more powerful than positive. It will neutralize this particular positive we are seeing here, and the end result will be 7 minus 2. 7 minus 2 is what? Is 5. That is for this particular example. Now, example number 2. If we have 3m raised to the power of minus 3 multiplied by 2m raised to the power of 7. In this case, the bases are attached to different coefficients. What we mean by coefficients are the numbers attached to variables. Now here we have 3 as the coefficient attached to m raised to the power of minus 3. And here we have 2 as the coefficient attached to m raised to the power 7. So the first thing here is to multiply the coefficient first before the variables. We are going to have 3 multiplied by 2. Then you also multiply it by m. Since m are the common bases, we now add their respective powers. So here we have minus 3 plus 7. 3 times 2, viewers at home, it will give us 6. Then multiply by m. minus 3 plus 7. Invariably, minus 3 plus 7 is the same thing as 7 minus 3. Then when we say 7 minus 3, it will now give us 4. So the end result is 6m raised to power of 4. That is for this particular example. So if we proceed to the next one, which says a raised to power of 2 multiplied by 4a raised to power of 3 multiplied by 5a raised to power of 9. In this particular example, as seen in example 2, the first thing is to multiply the coefficient first before the variables. The coefficients in these examples are 3 multiplied by 4 multiplied by what? 5. Then we now multiply it by a raised to power of what? 2 multiplied by a raised to power of 3 multiplied by a raised to power of 9. Here, 3 times 4, viewers at home, it will give us 12. 12 times 5 will end up giving us what? 60. Here we are going to have 60 multiplied by, now we have the common basis, which we are going to pick only one and add their respective powers. We now have 2 plus 3 plus 9. And the end result is going to be 60a raised to power what? 2 plus 3 will give us what? 5. 5 plus 9 will give us what? 14. So the end result is 60a raised to power of what? 14. Now, if we move to example number 4, which says m raised to power of 4x multiplied by m raised to power of 5x. Here, m is representing the base. 4x is representing the exponent. In this one, we have m as the base, and we also have 5x as the power. Now, the common bases are, the common base here is what? Is m. Then, after getting the common base, the next thing is to add their respective power, which is what? 4x plus 5x. If we have 4x plus 5x, it will end up giving us what? M raised to power 9x. That is in the case of this particular example. If we go on and on and on with this example, let us pick this one as the last one before we move to the next law. If we have 11u raised to power 5 multiplied by 7u raised to power of what? 7. In this case, we have the first variable attached to a coefficient 11 and the second one attached to another coefficient 7. And looking at our previous example, we says if we have a particular variable attached to a coefficient, we'll first of all multiply the coefficient first before multiplying it with the variable. Here the coefficients are 11 multiplied by 7. Then we multiply by u raised to power of 5, then multiply by the next u, which is raised to the power of 7. Now, viewers at home, 11 times 7. We are not in the exam hall. You are free to use your calculator or you are free to use your hand. Now, if you press your calculator, 11 times 7 will give us 77. Then multiply by u raised to power of what? 5 plus 7, which will end up giving us 77 u. Now, 5 plus 11. Do the counting on your own. 5 plus 11 will end up giving us what? 12. 5 plus 7 will give us 12. So this is the end of this particular example. So with this, we move to the next law. The next law is division law. Under division, if we have a raised to power m divided by a raised to power n, the end result is a raised to power m minus n. So if you look at this multiplication and division law, under multiplication, if we are multiplying two common bases together, the end result is what? We add their respective powers. But when it comes to division, if we are dividing a particular variable with another variable of the same base, what we do is what? We subtract the second one from the first variable. Now, if we are asked to simplify, so viewers at home, let us not be confused with this. Sometimes you see evaluate the following. Sometimes we see what? Simplify. Sometimes you see what? Solve. They all mean the same thing. Now, if we are to go with example number 1, which says 10 raised to power of 7 divided by 10 raised to power of what? 3. Following the rule that we have here, 10 is the common base. We are going to have 10. Then the first power is what? Is 7. Then we'll remove 3, which is the second power from the first one. Now, viewers at home, 7 minus 3 is equal to what? Now, 7 minus 3 is equal to 4. That is in the case of the first example. So if we move on to the next example, if we have 42y raised to power 12 divided by 3y raised to power of 5. In this case, as we can also see under multiplication, this variable is carrying a coefficient. Here, we'll first of all divide the coefficient first, which will now give us 42 all over what? 3. Then, we'll multiply it by y raised to power 12 divided by y raised to power of what? 5. Now, viewers at home, you can lay your finger on your calculator. Divide 42 by 3. But if you are not having calculator, first of all, we'll take it, since the denominator is a single digit, we can start with what? 1 digit. 4 divided by 3, it will give us what? 1. The remainder is what? Is 1. So if we add that 1 in front of the remaining 1, it becomes what? 12. 12 divided by 3, it will now give us what? 4. Meaning 42 divided by 3 will give us what? 14. Now, if we multiply by y, we say under division, we subtract the powers of the variables. So the first one is 12 minus 5, which will now end up giving us 14 y raised to power what? 12 minus 5. For those of us that are not very fast, you can still press your calculator. But for some of us that are guru in mathematics, you don't need to press your calculator. So 12 minus 5 will end up giving us what? 7. So the end result of this particular question, which says 42y raised to power 12 divided by 3y raised to power 5 is what? 14y raised to power of 7. So if we move to the next question, which says 19x divided by 19 raised to power x divided by 19 raised to power of y. In this example, 19 is what? Is the common base. And the exponents are x and y. So here we are going to have 19 raised to power of x minus y. This is where we are going to draw the curtain for this question. Because x and y are variables, which the values are not given to us. So we'll leave it as x minus what? Y. If we move to the fourth question, it says 15r raised to power of 14 divided by 3r raised to power of what? 11. In this case, we'll apply the same procedure we use in question number 2, which is going to be 15 divided by what? 3 multiplied by r raised to power of 14 divided by r raised to power of what? 11. Now, viewers at home, you have 15 oranges and you have 3 children, and you are to divide 15 oranges. You are to divide the 15 oranges for your 3 children. How much is each of your children going to have? 15 oranges to be shared for the 3 children. Each of them will get 5. Each of them will get what? 5. Then multiply by r raised to power of 14 minus 11. At the end of the day, we'll end up having 5r. Viewers at home, 14 minus 11. If you have 14 mangoes and you have to give 11 out to your friends, at the end of the day, you will be left with how many mangoes now? That is, you'll be left with only 3. So this is where we are going to draw the curtain for this particular example. But before I go, or before we put an end to these questions, I would like to give you a homework. Because they say all work without play makes Jack a dull boy. Now your homework goes this way. Simplify the following. Number 1, it says 7m raised to power what? 0. So number 2 says 7m everything raised to power what? 0. Number 3 says 7 raised to power 0 multiplied by what? M. At the end of the day, you send your answers to my WhatsApp account with number 07067547880, and make sure you stay home safe by obeying the standards set by NCDC, by maintaining good social distance. Wash your hands regularly with water and what? Soap. Avoid going to a crowded place. Thank you all, and God bless you for listening.